So, last class I have discussed how to calculate the earth pressure if it is the only soil with surcharge, and if the soil is below water table. Okay. But all the cases the backfill was horizontal. Now, this class first I will discuss that how we can calculate the earth pressure if the backfill is inclined. Okay. So, we will calculate the effect of sloping ground or inclined backfill, because in the previous cases your backfill was horizontal. Suppose if we have a wall, and the previous all the cases this is the backfill, because backfill is horizontal, perfectly horizontal. Now, if the backfill is inclined, say, which is making an angle I with the horizontal, okay, then how we can calculate the earth pressure. So, in that case, first if I take a element, and this element is also making an angle I with the horizontal. So, and this side is sigma h or sigma x, this side also it is sigma h or sigma s, this is sigma v, this is sigma v. Okay. Or sometimes you can write that this is your sigma z, and instead of sigma h you can write sigma x also. Okay. Sigma h means horizontal, sigma v means vertical, sigma x means also horizontal, sigma z means vertical. So, you can use either sigma v or sigma z, or you can use sigma h or sigma x, but in the previous cases I have used sigma x, here I am using sigma h. Okay. So, now this is the element, and so your sigma v I can write that sigma v is equal to sigma z cos I. Okay. How I am writing that, and another one that this angle is I. Okay. And if I draw a line which is perpendicular to this plane, okay, this is sigma n or sigma normal, because in previous cases your plane were perfectly either horizontal or vertical. So, sigma v is also sigma n normal, both the cases it was normal, but here sigma v which is acting in the vertical direction, which is not normal to this plane, because if your plane is perfectly horizontal, then the stress which is acting in vertical direction which is also normal to that plane, but here your plane is inclined. So, the stress which is acting in the vertical direction is not normal to this plane. The normal to this plane is sigma n. Okay. So, that is the normal, and here I can write the tau also, because initial cases the plane were the principal plane, because there was no shear stresses, but now these planes are not principal plane. This principal plane means where the shear stress is 0, but now this plane is not principal plane, here shear stress is existing. Okay. So, that means there will be a normal stress, there will be a shear stress both. Okay. So, I can write here, because if this is the in the vertical direction, this is the normal, this angle is I. So, this angle will also be I. Okay. So, from here I can write that my sigma n is what? Sigma n, this is sigma n, this is sigma v. So, I can write sigma n is equal to sigma v cos I. Okay, because this is sigma v, this is sigma n making angle I. So, this will be sigma v cos I. So, your sigma v is equal to gamma into z cos I. So, this is also cos I. So, this will be sigma z cos square I. Now, how sigma v is equal to sigma z cos I? Because in the previous case, when your plane were perfectly horizontal, that case we are making that one as a sigma v. Okay? Now, your plane has changed. Okay? This is change, which is making an angle I. So, now if I say that this is the sigma v dash. So, for this plane we are applying the same force. So, this plane is also your, if this is unit plane or unit distance 1 say. So, if this is 1, then this one will be 1 into cos I. So, this plane will be 1 into cos I. If this plane is 1, this is 1, because this is your 1, okay, and this is I. So, this plane will be 1, sorry, this plane will be 1 divided by cos I. So, suppose we have a, so that means the length of this plane will be how much, if this one is 1 unit length or unit length, then this one will be 1 divided by this plane, say L is the length, that will be equal to cos I. So, L will be 1 divided by cos I. Okay. Now, we are applying the same force. So, I can write sigma v into unit length, that is equal to sigma v dash into L. So, I can write sigma v dash is equal to sigma v divided by L. So, I can write sigma v 1 by cos I. So, that is equal to sigma v cos I, and sigma v is equal to gamma z. So, this is gamma z cos I. So, this the here the stress which is acting I am making as a sigma v. So, that is sigma v, or you can use this is as a sigma v dash and this one as a sigma v. So, whatever it is, okay. But in that case your sigma v dash will be the gamma into z. Okay. So, or you can write in this way, because I have written this is sigma v. So, I am writing in this way, this is sigma v dash, this is sigma. So, sigma v, this is sigma v will be sigma v dash is sigma v into L, or this is sigma v into L. So, I can write this is sigma v is equal to sigma v dash into L sigma v divided by cos, and sigma v was sigma v dash equal to gamma into z, which is acting on the unit length horizontal plane. Okay. So, this way you can write that your this stress which is acting on the inclined plane will be sigma z into cos I. So, sigma n normal stress is sigma v cos I, and this is gamma into z cos I cos I. So, gamma into z cos square I. Okay. So, similarly, tau the shear stress, which is this is the shear stress direction. So, shear stress will be sigma v sin I. Okay. So, this will be the sigma v sin I. So, sigma v is nothing but that your gamma z cos I, this is sin I. Okay. So, now we can get the normal stress and the shear stress, and both the values we know, this is gamma z cos square I, this is gamma z cos I sin I. Now, if I draw the Mohr circle for this case, this is sigma and this is the tau again, and this is the failure envelope, and again we are doing this for only friction soil. So, and if this is the Mohr circle. So, this is sigma 1 and this is sigma 3, for this is for the active case. But these stresses are not the stresses on this plane, because this is not the principal plane, and this stress is the principal stresses that we are talking about. So, now we can draw this is the line phi. Now, we are drawing a line which is making an angle I, because that is the inclination of the backfill. This is the making an angle I, that is the inclination of the backfill. Okay. So, now this line is passing with a point A and B to the Mohr circle. So, that means we have drawn a Mohr circle, this is the failure envelope, and sigma 1 and sigma 3 are the two stresses, principal stresses. But if those two are for principal plane, but these planes are not principal plane, because it is making an angle I with the horizontal. Okay. So, now if I draw a line I with line making an angle I with the horizontal, then A and B are the 2 points where it touches or it passes through the Mohr circle. Now, so now if I consider this A point, then I can write this is, if I draw a line perpendicular to this point. So, I can write this is as a tau, this as a tau, and this one is a sigma n, okay? Because that is the point where it is on the Mohr circle, and on the Mohr circle at this plane is the same as the plane that we are representing. This is the same plane, okay? It is also making an angle I. So, in this plane there is this shear stress and the normal stress. So, here also this is the shear stress and this is the normal stress of this plane or this point. Okay. So, now I can write that if this is the center of the Mohr circle, say O1, or O1 is the center of the Mohr circle, this is the origin, and if I join these 2 points, so this is say C2, and definitely it is 90 degree, and again I am drawing a line which is perpendicular to AB line. I am drawing a line on the AB which is perpendicular to the AB and it is passing through O1. So, this line is also 90 degree. Okay, I have drawn that. So, again I can write this radius of the circle is sigma 1 minus sigma 3 divided by 2, and this O1 from this origin is also sigma 1 plus sigma 3 divided by 2. So, O1 is sigma 1 plus sigma 3 divided by 2. Okay. So, this is the construction side of all the cases. Now, I will again write that from this Mohr circle I have already proved that sigma 1 minus sigma 3 divided by 2 is sigma 1 plus sigma 3 divided by 2 into the sin phi, that I have already proved. Okay. Now, how we are getting that? That if we have a we triangle O1 and C2, triangle O1 and C2, this triangle O1 and C2, I can write that sin phi is equal to C2 O1 divided by O1 Okay, this is the sin phi. So, and C2O1 is sigma 1 minus sigma 3 divided by 2 and O1 is sigma 1 plus sigma 3 divided by 2, because this is the O1 and O1 C2 is nothing but the radius, which is sigma 1 minus sigma 3 divided by 2. Now, this is the case. So, from here we will get this equation, the sigma 1 minus sigma 3 by 2 is equal to sin phi sigma 1 plus sigma 3 divided by 2. Now, if I take triangle O1 C1, if this point is C1, now I am taking this triangle. Okay, so, I can write that sin I is equal to, again this is the perpendicular line, O1 C1 divided by O1. Okay. So, I can write O1 C1 is equal to O1 sin I, okay, and O1 is equal to sigma 1 plus sigma 3 divided by 2 into sin I. Okay. So, now from this triangle O1 C1 B, now if I take this triangle, this O1 C1 and B, from this triangle O1 C1 and B, okay, this triangle I can write that BC1 square because is equal to O1 B square minus O1 C1 square, because this is B C1 square is equal to O1 B square minus O1 C1 square. Okay. So, here it is O1 B again the radius. So, this is also O1 B I can write. So, O1 B is the radius. So, I can write sigma 1 minus sigma 3 divided by 2 whole square minus O1 C1 square, O1 C1 is equal to sigma 1 plus sigma 3 divided by 2 and sin I. So, I can write sigma 1 plus sigma 3 divided by 2 square and sin I square. Okay. Now, sigma 1 minus sigma 3 divided by 2 is sigma 1 plus sigma 3 divided by 2 sin phi. So, I am replacing this. So, I am writing here sigma 1 plus sigma 3 divided by 2 whole square sin square phi minus sigma 1 plus sigma 3 divided by 2 whole square sin square I. Okay. Now, from here I can write that BC1 is equal to sigma 1 plus sigma 3 by 2, because this is square I am taking the root, then root over sin square phi minus sin square I. Okay. This is the BC1, BC square. So, will be BC1 square will be, if you take sigma 1 plus sigma 3 by 2 whole square common. So, this will be sin square phi minus sin square I. So, I am taking the root. So, this will give you the value. And similarly, again that your BC C1 and again this, if I join this line AC1 are both same, because this is the same value, because this is the equal, because these are radius, this is the common side between the two triangle, and this is 90 degree, this angle of 90 degree. So, this angle 90 degree, this angle 90 degree, this is the common side, this BO1 is equal to your O1B is equal to O1A, and this is 90 degree. So, this we can write that A C1 is equal to B C1. Okay. Thus, AC1 is equal to BC1. So, I can write AC1 is also sigma 1 plus sigma 3 divided by 2 sin square phi minus sin square I. Okay. Now, we will go for the next part, that here sigma v is how much? From here in this line sigma v, now I am taking sigma v. Okay. So, sigma v is what? Sigma v is OA. How I am getting that? Because this is your sigma n, this is I. So, sigma n is this one and this is I. So, this will be definitely the sigma v, because I have already proved that sigma n. So, I can write that sigma v divided by sigma n is equal to 1 by cos I. Okay. Or I can write that cos I is equal to sigma n divided by sigma v. So, now if you look at this one, this is sigma n and this is the I. So, definitely this will be the OA will be the sigma v. Okay. Because that is, you know that if I draw this one, this is sigma n. So, this will be the sigma v and this is the tau. So, this is the sigma v is OA. So, I can write OA is nothing but OC1 plus AC1. Okay. OA is OC1 plus AC1. Now, what is OC1? OC1 I have already got that OC1 is equal to, this is equal to, this is the cos. So, I can write OC1 is sigma 1 plus sigma 3 divided by 2 into cos I, because this is the OC1. How I am getting this? Because if you take this triangle, if I take this triangle OO1 C1, so this is I, this is 90 degree. So, this value is O1 is sigma 1 plus sigma 3 by 2 and I am getting this OC1. So, that will be sigma 1 plus sigma 3 divided by 2 into cos I, okay, from this triangle. So, this is the cos I plus AC1 and AC1 is this value. Now, finally, if I write that sigma v is equal to sigma 1 plus sigma 3 divided by 2 cos I plus sigma 1 plus sigma 3 divided by 2 root over sin square phi minus sin square I. Okay. And here sigma h is equal to P A. Okay, this is the horizontal stress and it is the active case, and the sigma h value is, from this Mohr circle we can write sigma h value is how much? Sigma h value is, if this is the sigma n, and then sigma h value will be O C1 minus B C1. Okay. So, sigma h value will be, this one will be the sigma h value. Okay. So, this is the sigma h value, that O C1 minus O or B C1. So, that means this is the sigma h value, because we got this is total 1 sigma v value. So, I can write that sigma v is equal to OA. I have written that. Now, this is the sigma h is the stress which is the lateral stress and which is smaller than the sigma v. So, we can write that sigma h is equal to O B. Okay. Sigma v is equal to O A and sigma h is equal to O B, because this is the smaller stress. So, now I can write that sigma is equal to sigma A is equal to O B, okay, O B, and O B is nothing but O C 1 minus B C 1. Okay. So, I can write O B is equal to O C 1 minus B C 1, and again the O C 1 is sigma 1 plus sigma 3 divided by 2 into cos I. I have already written this is minus B C 1, which is sigma 1 plus sigma 3 divided by 2 root over sin square phi minus sin square I. So, I can write that finally, sigma h divided by sigma v, which is sigma h is P A, this is sigma h is P A, and sigma v I have written sigma v is equal to gamma into z into cos I. So, I will write sigma v is equal to gamma into z into cos I, that is equal to, again I can write sigma h is in this form. So, this is I can write sigma h in this form also. So, this is sigma 1 plus sigma 3 divided by 2 into cos I minus sigma 1 plus sigma 3 divided by 2 root over sin square phi minus sin square I, and sigma v also I can write that sigma v sigma 1 plus sigma 3 divided by 2 cos I plus sigma 1 plus sigma 3 divided by 2 root over sin square phi minus sin square I. So, I can write sigma h as a P A, and I can write sigma h also this expression, okay, and I can write sigma v is equal to gamma z into cos I, also I can write sigma v with this expression. So, I have written that. So, now if sigma 1 plus sigma 3 by 2 we can cancel. Okay. So, I can write this is cos I minus root over sin square phi minus sin square I divided by cos I plus root over sin square phi minus sin square I. Okay. Now, here all the terms are in cos. So, we can represent them in terms of cos also. Now, if I convert this sin to cos, so then I can write cos I minus root over 1 minus cos square phi minus 1 plus sin square phi sin square I. So, finally, I can write this sin square phi I can write 1 minus cos square phi, and this one I can write 1 minus cos square I. So, this 1 will cancel and this will be cos square I minus cos square phi. Similarly, this is cos I plus root over cos square I minus cos square phi. So, finally, the P A active pressure is gamma into z cos I minus root over cos square I minus cos square phi. This is cos I plus root over cos square I minus cos square phi. So, I can write gamma z into K A. Okay. So, where this K A is again the coefficient of active earth pressure, and K A I can write cos I minus root over cos square I minus cos square phi divided by cos I plus root over cos square I minus cos square. Okay. So, this is the inclined one, and now finally, the earth pressure for the inclined surface, this is the wall. So, this will act parallel to the backfill surface. So, this is finally the P A, and the P A will be, again we can write that P A is equal to half into gamma into K A into H square. So, this is the H, okay, or this is the H is the height of the wall, and later on I will show you that H calculation also we can change depending upon where I am applying this force P A, but here I am applying this force P A. So, then this will be the H. Okay. So, that means H square. So, here K A, remember that this is this expression, and again this is acting at the height of H by 3 from the base of the wall. Okay. So, but that means the P A is here acting at an angle of I with the horizontal. Okay. Previous case P A is totally horizontal because the backfill was horizontal, now backfill is inclined. So, in this case P A will always act parallel to the backfill surface. If backfill is horizontal, P A is also horizontal. If backfill is inclined, P A is also inclined with that angle of inclination with the horizontal. Okay. So, that means here P A is acting with an angle I with the horizontal, because this is also I, this backfill surface. Otherwise, this is the expression. So, similarly for the K P, it will be the opposite. It will be sin I plus, and this will be this is cos I plus, this will be the cos I minus, and this will also change, because you can derive that expression also, because in that case your sigma 3, sigma 1, that thing will change. Okay, that I have discussed in the last class. So, this is the incline, this is the earth pressure of a inclined backfill according to the Rankine's theory, because this is the Rankine's theory has been extended, because original Rankine's theory it is for the horizontal backfill, but it is the inclined backfill which has been extended. So, next class I will discuss about that how I will determine the earth pressure if the soil is a C phi soil. Here we have considered all the soil where the C is equal to 0, only the phi value is there. Now, in the next class we will discuss what will happen if the soil has both C and phi. Thank you.